Let us start with some basics of statistics. Statistics is a science of collecting huge amount of data and trying to use them to infer and predict some information out of it. So when you start with statistics, let's go simple first. So when you have a single variable data, for example, let's take we have a data about the height of different peoples, and now if you want to show to a group of people, will you show this number as it is? It doesn't make sense altogether. So when you are going to share this data with the people, you will try to show them the central information as the first point. So central information is what? Trying to show them what's mean, median, or mode. As you know, the mean is simple arithmetic mean, summing all the number together with the count of number in bottom. And mean can be in different way, depends on the data. Either arithmetic mean is a normal, mostly used one. Sometimes you may use harmonic or geometric mean, and there are dedicated videos around that. You can look at it. And median is the 50th position, like P50 kind of position data, and mode is the data that is repeating more frequently. So for example, if you see here, instead of giving this number as it is to people, if you say on an average, people height is 5.5, that makes very easy to understand, right? And here you could say median is 0.5 and mode is also 5.5. So here mean, median, and mode are same. Sometimes it can be different as well. It's possible technically, but eventually what you're trying to do here is first you will try to show the central tendency of the data, a single variable, so that it is easily comprehensible to the people. And then the central tendency shows the middle value of the information. And then the next information that can easily help us to understand what kind of data it is the variation, how the data is distributed. How you can say the variation range, its minimum to maximum, interquartile range. It's just showing how the 50% of your data is arranged, and absolute mean deviation. It's like comparing the variable with the average for the count of data. So this looks very simple and clean to use, but most of the time people go ahead and use standard deviation, not the absolute mean deviation. It is just because absolute mean deviation is having a modulus, which means you are ignoring the plus and minus symbol, and further arithmetic process became complex. So we don't use this very frequently. We use standard deviation, just similar to this. We square them and make a square root out of it. So it's like, for example, now you know the average. If you calculate standard deviation, range, and AQD, you could say that even though the average height is 5.5, the people height vary in the range of 0.8. So, and then you could see the standard deviation is 0.18. So what it means to say is, on an average, 68% of the people lies in between 5.5 plus or minus this number. 68, I say usually the standard deviation is used more predominantly with normal distribution, even though this data is not normal distribution. I'm just giving it as an example. And here the average distribution and IQD. IQD is based on the P25 to P50. What is that range over here? So here, this is a measurement of variation. Maybe if you have two variables, you want to compare them, you can compare them with the help of coefficient of variation, which is the standard deviation divided by mean, which will show you if that data vary in the similar kind of fashion. There's a dedicated video around that. You can look at that as well. And then once you show the central tendency and then you show the distribution, the next thing that can make people understand the information very easily is the direction of distribution. The first direction is skewness. Skewness calculation gave a very simple formula comparing mean and mode. So for example here, mean is located here. What it means is there is a skewness in positive side. So this side, maybe there is some outlier locating here. It is pulling the mean away from median and mode. The same way here it is negative. It's because there is some outlier in this area which is pulling the mean away from median and mode. And there are two possible ways, Hall and Boyle's. There's another thing. When you say moments, as you know, the moments is like 0 first and like it is the power of x minus x bar kind of information. And here, the second degree comes as a standard deviation or variance. And the third degree is part of skewness. So, for example, when you have a cube of x minus x bar, it's like it can become 0 only if both the direction are symmetric over here in the chart. So it can be found with this formula as well. But this formula will not help you to understand the direction of skewness. The direction of skewness you may need calculation or Bowley's formula. And then the next thing is kurtosis. Kurtosis you are trying to see in the fourth moment. When you have the fourth moment, if it is 3, it means it is meso, which is a normal distribution. And then if it is greater than 3, it is left out. Less than 3 is flat out. It's like the moments are something like x minus x bar to the power 1 to the power 2 is second moment, to the power 3 is third moment, to the power 4 is fourth moment. And anyway, this is expanded formula. When you divide these with this